today we are talking about dividing polynomials. So up until now we have talked about operations with polynomials. We did some addition, subtraction, and multiplication. Today we're dividing because there's a little bit more of a process to it. So we take a whole section, and there's actually two different ways. We're going to do long division, and then we're also going to do something called synthetic division, which is brand new. We haven't done that before. So we're going to take a look at what that means as well. So let's go ahead and jump right into it, doing some examples. So for this particular one, when you have just one monomial that you're dividing by, so if you don't have a whole polynomial, if you just have one thing in the denominator, essentially what we can do is we can just rewrite this and create several mini fractions out of it. Then we have plus, and then we have 8xy squared over 4xy minus 12x squared y cubed over 4xy. So I just distribute essentially this to each denominator, and now I can simplify using exponent rules. So 4 over 4 will simplify and go away. X cubed over x is just x squared. Y squared over y is just y. 8 over 4 is 2. X over x cancels. And y squared over y is going to be just y. Minus 12 over 4 is 3. X squared over x is x. And y cubed over y is y squared. You look to see are there any like terms, there are not, so this is our final answer. So that is technically a way of dividing it, so I guess you could call that a third way. It's just writing each one, and we're really using the exponent properties there. So you'll see those occasionally from time to time, but those are not what we're going to be focusing on. It's just one of the ways that you can simplify some of these fractional ones. When we actually jump into division, we have this one specifies they want us to use long division. So if you recall long division, now this is I'm asking you to go back to elementary school stuff here. If you have long division, I'll do one off to the side here. If you have 48 divided by, we'll say 6. You identify and you say, okay, how many times will 6 go into 44? We'll go in there 0 times. So I move on. How many times will 6 go into 48? What actually goes in there 8 times? 8 times 6 is 48. We subtract, I end up with 0. So my answer is 8. We're doing a similar process here. The first thing goes on the inside. So I have z squared plus 2z minus 24 divided by z minus 4. So that goes on the outside. For now, I ignore this piece here. What I'm looking at is the z. And I want to tell myself what times z will get me z squared. Well, that's going to be just z. Because z times z is z squared. But then I want to distribute that. So z times negative 4 is minus 4z. Now just like over here, we subtract. So I want to subtract here, which means I'm really going to distribute that negative to the whole thing. So z squared minus z squared gives me nothing. It cancels out. 2z minus a negative 4z actually adds it, so we end up with a positive 6z. And then I bring this down. So then I have minus 24. And then I ask myself, what times z gives me 6z? Well, that's 6. So I'm going to add a 6 to the top. So 6 times z gives me 6z. 6 times negative 4 is a negative 24. When I subtract the whole thing, we get 6z minus 6z cancels. Negative 24 minus a negative 24 is negative 24 plus 24, which gives me a remainder of 0. So my answer then would be z plus 6. So all you want to do is ask yourself, you're looking at the very first term only, ignore this at first. You say, what times this is going to get me this, the first term here. Then you distribute that to both, subtract, and say, okay, now I'm looking at my new first term. What times this first term will get me this first term? Distribute it, subtract, and you want to go until you run out of terms over here to bring down, and that's it. So you might have a remainder sometimes, that's okay. But but that's using long division. And we can go over that more in person. I feel like that's one of those ones that I do need you to know that, but it's not super necessary, especially once I show you this next way that kind of cancels out all of that. So the next two examples are actually using something that we call synthetic division. Now synthetic division is just defined as a simpler way of doing polynomial division. However, we have to have a couple specifications. The only thing that has to be true is you have to have a binomial here. With long division you can have as many things here as you want, as long as it's not bigger than this. Here we have to have a binomial to make this work. Whoops. So what we want to do synthetic division, I start with this one, and I want to write out only the coefficients. So I take 5, negative 13, 10, negative 8. And I put those inside a box. Leave some space because there is a second row that goes inside of our box. Now I look to this one. What you want to do is you want to take this second term here. So for long division we look at the first term. For synthetic division we look at the second term. You want to take the opposite of this sign. So you want to say, I want to divide this by a positive 2. So what we're doing is we're eliminating all the variables here, and we're just working with the coefficients and the numbers. The way you do synthetic division. Now once you get the hang of this, it's going to be super easy, but stay with me. You bring down the first one as is. Don't change the thing. Then you say 5 times 2 is 10. And I bring that here, and I add. Negative 13 plus 10 is negative 3. Then I multiply. Negative 3 times 2 is negative 6. I add. 10 plus a negative 6 is a positive 4. Times 2 is 8. Negative 8 plus 8 gives me a remainder of 0. So my answer here, so that's our remainder. The answer down here, whatever we started with, you take it down by a degree of 1. So I'm going to start with 5x squared minus 3x plus 4. This is your answer. So with synthetic division, we start by using all the coefficients of the first thing, and we write those in a line. Then we make ourselves the box, and we take the opposite of this one and put that on the outside. You bring down the first one, the numbers across the bottom you multiply by this, and then you add them to the one here. So 5 times 2 is the 10, and you add those. Negative 3 times 2 was negative 6, add them. 4 times 2 is 8, add them. And again, you might end up with some remainders here eventually. We'll get into more details with what that means and what we're looking at there, but for right now I just need you to be able to do this division, because we are going to be applying this division on how to solve some problems later on in the chapter. So it's important that you grasp this concept before moving on. Let's go ahead and take a look at one more. So again, we're going to do some synthetic division. However, with this one it's a little different. Just like with completing the square, in order to do synthetic division, this first term has to just be an x. Not 2x, not x squared, just an x. So what we have to do, pretty much, is we're going to take all of these things and kind of write them as if we were going to do long division, or even just as a fraction. And what you want is to get this to be just an x, I have to divide it by 2. Well, if I divide it by 2, everything has to be divided by 2. So all I'm going to do here is divide this whole thing by 2. So we get 4x to the 4th minus 2x squared plus 1/2 x plus 2. And in the denominator, we end up with x plus 1/2. So that's our new thing. So now we're going to take a minute and we're going to write that synthetic division using those coefficients. So remember, we use the coefficients. Now notice, what's happened here? We have 4x to the fourth minus 2x squared. We skipped the cubed term. Because it's not there, we have to leave a space for it and put in a 0. Because you want to account for every number, starting with the biggest and working your way down. So if it skips one or two of them, you have to incorporate a 0 in order to do that. So when I write out my synthetic division, we're going to have 4, negative 2, oops, excuse me, I'm just breaking the rule I just taught you. So we have no cubed, so I'm going to have 4, 0, negative 2, 1/2, and 2. Make our box. Remember, take the opposite sign, so I actually want a negative 1/2, and now I can bring them down and start. So 4 times negative 1/2 is negative 2. Add, that's going to give us a negative 2. Times negative 1/2 is a positive 1. Add, we get a negative 1. Times negative 1/2 is a positive 1/2. Add, we get a positive 1. Times negative 1/2 is a negative 1/2. Add, we get 1.5 or 3/2. So even though we didn't get the 0 there, it's okay because we have that synthetic division. And we can have the remainder there at the end. So I have 4x cubed, remember you go down by 1, minus 2x squared minus 1x plus 1. Now, really what you do here is you do plus, we're going to have 1.5 over whatever this denominator was. So you just have 1.5 over 1 plus 1/2. Now really, if you wanted to get rid of all the fractions and decimals in there, we could multiply it by 2 and end up with 4x cubed minus 2x squared minus x plus 1. Multiply both top and bottom by 2, and I end up with 3 over 2x plus 1. So I ended up back with the original that I had and the remainder of 3. So then my final answer would be this. So the process of synthetic division is not hard. These get a little complicated when you have something that's not equal to 1 in front of the x. But the main process I need you to comprehend right now and to focus on is this process here. So bring down the 4, multiply and add. Multiply and add. Multiply and add. It's just a repetition of that multiplication and adding. So your homework in this is 13 through 33 odd. Some of those you're going to be using the first example where you just can simplify. Some of those you're going to be using the second example where you need to use long division. And some of those are going to be asking you to do synthetic division specifically. So be sure to have your notes in class. Be sure to have your books and things so you can do the homework in class. And I'll be checking over that tomorrow.